Alright, the next example on areas in a plane is number 4. Find the area enclosed by y cubed equals 4x, x is 0, and y is negative 2. So, first thing, I don't know if you want to think about this as y equals the cube root of 4x. That might help you with that one. I'm not sure if it will. But what we want to do is we want to graph this so we can see what area we're looking for. So you could put that in your calculator that way to see what that graph looks like. That's probably the best thing to do. I know x equals 0 is one of my boundaries. Y equals negative 2 is one of my boundaries. I'll go ahead and put that one. That's the easy part. Y equals negative 2. And then when we put this in our calculator and see what it looks like, we find out that it looks about like this. Goes through the origin and it crosses negative 2 somewhere out here. I should have done the intersection first. Let's find the intersection. And remember to do that, just set the two things equal to each other. Actually, what two functions do we want to use? Well, you want to use y equals negative 2 and y equals 4x to the 1/3 power. Okay, I'm just going to start with y cubed equals 4x, and I know y equals negative 2, and basically I can substitute y equals negative 2 into that. So I get negative 2 cubed equals 4x. Negative 2 cubed is negative 8 equals 4x, so x is negative 2. So the intersection is at x is negative 2 and y is negative 2. And the area that I'm looking for then is this area in here. And if you remember from Friday, the area enclosed between two curves is equal to the integral of top minus bottom function. And the other thing I want you to think about is really what we're doing is summing up a bunch of rectangles just like that. Okay? Where the height of this rectangle is this top function value minus the bottom function value. That's why this works here, top minus bottom. So here we go. We want the integral, and our boundaries are going to be from negative 2 to 0. The top function is this, 4x to the 1/3 power. And you do need to have that in this form. I can't use the y cubed here because I need it to be a function in terms of just y equals. So 4x to the 1/3 power minus this function, which is negative 2. Watch those negative signs there. Dx. So just as a reminder here, remember this is the height of the rectangle. This is the width. So we're just summing up a whole bunch of rectangles there. And what do we get here? This is going to be the integral from negative 2 to 0. If we clean this up a little bit, 4x to the 1/3 power. Hey, by the way, don't forget those parentheses too, because the 1/3 power applies to the 4 as well as the x. This is now going to be a plus 2 dx. And this we can just anti-differentiate. What I'd like to do is separate the whole number here from the variable, so I'm going to do that. Negative 2 to 0, 4 to the 1/3 power times x to the 1/3 power, all plus 2. So the 4 to the 1/3 power is now just a constant out in front. Antiderivative then would be 4 to the 1/3 power times, what is this going to be, x to the 4/3 power divided by 4/3, which is the same as times 3/4, plus antiderivative here is just going to be 2x. I've got to evaluate that whole thing from negative 2 to 0. first plug in the zeros. If I plug in 0 to these terms, I'm just going to get 0. Minus, plugging in -2, so I have 4 to the 1/3 times 3/4 times -2 to the 4/3 power plus 2 times -2. And if you work all that out, save us a little bit of time, you get +1.